So in the earlier lecture, I talk about homogeneity of space, and that leads to law of conservation of linear momentum. Now I will talk about today the homogeneity of time, and this homogeneity of time leads to the law of conservation of momentum. Law of conservation of energy. So here I will consider the time translation. When I consider time translation, then t will become t prime, and it is equal to t plus delta t. And let us assume that under this time translation, Lagrangian will changes to L prime such that it is equal to L plus delta L. And according to homogeneity of time, that L should remain invariant. That means delta L should be equal to 0. But if I so delta L should be equal to 0, and if I try to find out delta L, then it is delta L is equal to curly Ly curly t into delta t. It can be evaluated like this. And for delta L to be 0, that means curly Ly curly t must be equal to 0. But if I recall, or if I try to find out dl by dt, and it is t upon dt, where Lagrangian is a function of ri dot and t, then it can be evaluated as that it is curly L over curly ri dri upon dt plus curly L over curly ri dot tri dot upon dt, and it's summation over I and curly Ly curly t. So let us recall the Lagrange's equation of motion. If I recall the Lagrange's equation of motion, that means curly L over curly Ri must be equal to d upon dt curly L over curly Ri dot. So if I use this here, then this dl upon dt, it can be written as summation over I d upon dt curly L over curly Ri dot, and it is dri upon dt plus summation over I curly L over curly Ri dot, and dri dot upon dt, and also it is equal to 0 because of the isotropy of homogeneity of time, right? It we have assumed here, right? So if I use this here, then this will become 0. So if this will become the 0, then this is equal to this one, and this is ri dot. This is ri dot. So that means I can rewrite down this as summation over I d upon dt curly L over curly ri dot and ri dot plus summation I curly L over curly ri dot and dri dot upon dt, and these can be collectively written as, because this is separate and this is this, so this is like a product of two functions, so it can be written as d upon dt curly L over curly ri dot into ri dot therefore d upon dt L, it must be equal to d upon dt. This can be taken outside and I will take it outside. So it is curly L over curly Ri dot into Ri dot, right? So we can write down it like this. So let me club these two terms. So if I bring this towards that side, then it can be written as d upon dt summation I curly L over curly Ri dot into Ri dot minus L, and it must be equal to 0. So derivative of time derivative will be equal to 0. So that means this term must be constant. This term must be constant. Means curly R over curly Ri dot minus L. It's a constant of motion. It's a constant of motion. But this cell is basically T minus P and half MI dot square minus B R1 R2 and so on, and its summation. So if I try to find out it, then it is MI dot and it will be 0. So if I put these values here, then I'm getting that this is equal to summation over I. It is MI Ri dot. It is the value of this one minus half MI dot square minus B and this is everything will be constant, right? So that means it is summation will also be there, and if I club these two terms together and open this bracket, then it is summation MIRI dot minus half MIRI dot square, and yeah, it is Ri dot will also be there, right? So Ri dot will also be sitting here, so it means it is into into Ri dot, so it is Ri dot square, right? So and this minus minus will become plus, so it can be written as 1 by 2 MIRI dot square, because if I simplified, this is equal to this one summation over I plus P. So this is a constant and this is constant, and similarly now this is basically kinetic energy total, and this is the total potential energy, and it is the constant. Thus total energy of the system is constant. Thus total energy is constant, which is the law of conservation of energy. Thus homogeneity of time leads to the law of conservation of energy, and which is a consequent of time translation. So that's all for this lecture.